Hello everyone and welcome back to another video of Matuklasan. And in this video, we will talk about combination. Let us consider the possible arrangements of the letters A, B, and C. So if we were going to consider different arrangements, we could have A, B, C, A, C, B, B, A, C, B, C, A, C, A, B, and C, B, A. Now remember that in permutation, the arrangement of the objects is important. So if we're asking for the permutation of these three letters taken three at a time, then the answer is 6. So we have 6 ways to rearrange this. But in combination, the arrangement is not important. So ABC is the same as ACB and BAC. So the answer here is just one way. If we're asking about the arrangement of these objects of these three letters taken three at a time. So if the order of the arrangement is not important, then we say that each arrangement is the same. We say there is one combination of the three letters. And by this, we have the combination rule, wherein the number of combinations of R objects from N objects is denoted by NCR. And the formula is given by NCR equal to N factorial divided by N minus R factorial times R factorial. Is the same as looking when we're looking for this written notation. So if you have C and R here, then it's the same as NCR. Now, let's have an example. Say we are looking for the value of 5C0 or the combination of 5 objects taken none at a time. So in this case, we have 5 factorial, okay? And that is equal to 5 minus 0 factorial times 5 factorial, or rather 0 factorial, because n is 5, r is 0. So 5 factorial divided by 5 minus 0 is 5, so this is 5 factorial. And 0 factorial is just equal to 1. And it's the same as dividing 5 factorial to 5 factorial, so the answer here is 1. Now, what if we are looking for 5C5? So here n is 5, and then we have n as 5, and then the r is also 5. So we have times 5 factorial here. So this is 5 factorial divided by 5 minus 5, that is equal to 0. And 5 factorial is just 5 factorial here. Now, 0 factorial is equal to 1. So therefore, it's the same as the previous example wherein it's just equal to 5 factorial divided by 5 factorial, and that is equal to 1. Now, if you're going to look for 6C0, the answer will also be 1. And if you're going to compute for 6C6, the answer will also be equal to 1. And from this, we can extend the formula that if we happen to see n C0, the answer here is always 1. Or if you have n C n, wherein r is just equal to n, the answer is also always equal to 1. Now, how about if we are looking for the combinations of 5 objects taken one at a time? So the answer here is 5 factorial divided by 5 minus 1 factorial times r is equal to 1. So this is 1 factorial. So 5 factorial is just what? Equal to 5 factorial divided by 5 minus 1, which is 4. Okay, then times 1 factorial. So this is 5 factorial divided by 4 factorial because 1 factorial is just 1, right? And we can rewrite this as 5 times 4 factorial divided by 4 factorial. Divided, the answer is 5. So notice that 5 is just the number of n. And now, we can extend again this formula that when you are taking or rather finding the combinations of n objects taken one at a time, the answer is always the number of objects or elements, which is equal to n. So if we have 7C1, the answer is always 7. The number of combinations can also be easily performed using a calculator. So all you have to do is to look for the NCR option on your calculator. In my case, the NCR formula is above the division operation. So say I'm looking for 5C1, I just need to press 5 and then shift for me to choose the C or the NCR option, then 1. So that the answer is, as we all know, is 5. All right? So if we are finding for the number of combinations for 8 objects, say taken 5 at a time, that is 8C5. And 8C5 using your calculator is equal to 56. Now let us try answering combination problems. In this example, how many combinations of 5 objects are there taken 2 at a time? So n here is equal to 5 and r is equal to 2. So we have 5c2. Using the combination rule, we have 5 factorial divided by 5 minus 2 factorial times 2 factorial. We have 5 factorial divided by 5 minus 2 is 3 factorial times 2 factorial. So we can now change 5 factorial using the permutation, or rather the factorial rule. So we can rewrite this as 5 times 4 times 3 factorial. And then 2 factorial is just 2, while 3 factorial will just be written again because 3 factorial here will be cancelled, right? So 4 divided by 2 is equal to 2, and 5 times 2 is equal to 10. For you to review the operations that I did here, you can check out my video about factorial notation. Now, let us verify our answer using a calculator. So we have 5C2, and the answer should be equal to 10. In order to survey the opinions of tourists in Tarlac City, a researcher decides to select 6 tourist destinations from a total of 11 tourist spots in the said area. Now, how many different ways can the selection be made? Now, for us to easily identify the combination formula for this problem, we need to identify if, or determine if, the arrangement of objects is important or not. Okay? So in this example, selecting 6 tourist spots from 11 won't matter, right? The arrangement won't matter because it did not state in the problem. It is not stated in the problem that the arrangement of going to these tourist spots is important. So it doesn't matter if you went to the first destination first instead of the second. So here in this problem, the arrangement of, or the way we go to specific tourist spot won't affect our sampling. So this is a combination problem. So the n here is 11 and r is 6. So the formula now is 11c 6. So we have 11 factorial divided by 11 minus 6 factorial times 6 factorial. So we'll have 11 factorial divided by 11 minus 6, that is 5 factorial. Now, if you're using the factorial notation rule, you just need to choose the highest number here. 6 is higher than 5, so let's have 11 times 10. times 9 times 8 times 7 times 6 factorial. So you stop in 6 factorial, okay, for you to easily divide 6 factorial by 6 factorial. So using your calculator, we'll have 462. Now, you can also choose to enter the values in a calculator. So this is just 11 C2. Or I think I got the wrong keys there. 11 C6. It's not 2. Okay, so that the answer is equal to 462. For this next example, Yuno has 10 books to review. However, only 3 books are needed in his book report. How many different ways can these 3 reviews be selected? Notice here the arrangement is not important, right? Because if Yuno has to submit a book report, it doesn't matter if in any order he would like to report the 3 books. So it could be the first book first, followed by the sixth book or the fifth book. So all we need to do is to use the combination formula for us to identify the number of ways to select 3 book reports. So 10 here is N, while 3 is R. So we have now 10 C3. This is 10 factorial divided by 10 minus 3 factorial times 3 factorial. So we'll have 10 factorial. 10 minus 3 is 7. So we have 7 factorial times 3 factorial. So we'll have 10 factorial divided by, all right, 7 times 3. And by using the factorial notation rule, we can rewrite this up to 7. So 10, 9, 8, 7, because 7 is the highest here, so we would stop here. 7 factorial divided by 7 factorial is just equal to 1. And then 9 divided by, oops, I think I need to rewrite it first here. So 10 times 9 times 8, 7 factorial was already removed. Here we only have 3 factorial, which is equal to 3 times 2 times 1. So 9 divided by 3 is 3, while 8 divided by 2 is 4. So 10 times 3 times 4 is equal to 120. You can verify our answer, okay, using the calculator. So Yuno has 120 ways to select 3 books for his book report. How many ways can a club advisor choose 7 students from a class of 15 if they are all assigned the same task? So remember, the arrangement of the students here won't matter because they will just do a same or the same task, right? So if in case a different tasks will be assigned to these students, then you need to use permutation. But since the advisor just needs to choose 7 students from a class of 15, then this is just a classic example of combination. Now, N here is 15, while R is 7. So the formula is 15 C 7. That is equal to 15 factorial divided by 15 minus 7 factorial times 7 factorial. So we'll have 15 factorial divided by 15 minus 7 is 8. So times 7 factorial. Now, what if you have a calculator but you don't have the combination formula, but you have at least the factorial notation? So you can also enter this using your calculator by the use of formula. So 15 factorial divided by, okay, open parenthesis, 8 factorial times 7 factorial. so that the answer is 6,435. And of course, we can check that by directly pressing 15C7 on your calculator if you have one. So the answer is also 6,435. In this example, we need to determine how many ways can two cards be selected from a standard deck of 52 cards, disregarding the order of selection. So the order or the arrangement here is not important. So it doesn't matter what type of card will you going to select from the 52 deck of cards or a deck of cards containing 52. Okay? So N is just 52 while R is 2. So 52 C2 is equal to 1,326. Now, how about we level up the problem? So for this example, in a club, there are 8 women and 6 men. Now, a committee of 4 women and 3 men is to be chosen. So notice that we're going to need the counting technique or the counting method here, which is specifically multiplication rule. So if you want to check out the lesson about the counting methods or the multiplication rule, you just have to browse the playlist under this problem or lesson. So for this problem, we actually have two possible events, and that is choosing the 4 women first from the set of 8 women. So we need to select 4 women, and the other event is choosing 3 men. Okay? So by counting principle, this is the first event, while this is the second event. Now, the formula for us to get 4 women out of 8 women is just by the use of combination rule, because as you can see, the order is not important when we choose this group of women from 8. So we have 8 because n here is 8 and r is 4. So we have 8c4. Now the other event is for us to choose 3 men from the set of 6. So that is 6 because this time the n is 6 and the r here is 3 for the men. So we have 6c3. But we don't stop there because there actually a committee that is being formed composing of 4 women and 3 men. So what we need to do is to use the multiplication rule for us to get the number of possible arrangements to these combinations. And now, by using your calculator, 8c4 is equal to 70, while 6c3 is equal to 20. So all you need to do now is to multiply 70 and 20 for you to get 1,400. So in this problem, there are 1,400 ways for us to arrange a set of 4 women and 3 men in a committee. Now, this example is actually the extension of the previous example, wherein a box contains 3 white balls, 2 black balls, and 4 red balls. And in how many ways can 4 balls be drawn from the box if at least 1 red ball is to be included in the draw? So remember that we have 3 white balls here. So the number of white balls is 3. The number of black balls is 2. And the number of red balls is 4. Okay? So remember that we need to draw 4 balls containing at least 1 red ball. So for example, the first draw is red. followed by black, followed possibly by white, another black, and another white. Oh, or rather, we're done. This is the first possible combination, right? Because we have at least one red ball here. Or we can also have two reds, while it doesn't matter if you have two blacks, two whites, or one black and one white. Okay? Or it could be three red balls, and this last one could either be black or white. Or all the balls are red, because the condition just tells us that it should have just at least one red ball. So at least it has one red ball. Okay? But notice here that this one is tricky because it doesn't really matter actually if you have a black or a white ball as long as you have red balls in it, right? So now we will just group the white balls and red balls as non-red balls. Adding it, we have 3 plus 2, and that is equal to 5. Now, by using the counting method, we have different possible events here. The first one is getting, say, one red ball, and then getting, say, three. Oh, I have to change this to one red ball, so just one R. Okay, let's just code it one R, meaning one red ball. And then we have here three non-red balls, so say 3N. Okay, or we could actually have two red balls, right? And two, say, non-red balls. So remember, the sum should always be equal to 4. That is why one red ball plus three red balls, that's equal to 4 balls, right? And two red plus two non-red is also equal to 4 balls, because we have to draw 4 balls from the box. But at the same time, considering the given that we should have at least one red ball. So the first scenario is getting one red ball and three non-red. So when we say non-red, it's either white or black. Doesn't matter, because the arrangement of the the arrangement of the balls is not important here. Okay, so we have one red ball, three non-red balls, and then we could also have three red balls, right? While we just have one non-red ball. Or the last one is that we have four red balls. All of the balls are red, and there's now no non-red ball. Okay? Now, for us to use the combination formula, just like in the previous example, we identified the number of combinations that we could get given our total number of options for red ball. So here, in the first one, we need to select one red ball from how many red balls in the box? We have four red balls in the box, so and there is four, while we need to select one red ball, right? So here in this event, you have four red balls in the box, but we only have to choose two from it, right? So in the box, we have four again, but here in this event, we just need three. And here, four red balls in the box, and we should get four red balls from there. Okay? Now, remember that the total of non-red balls is 5. So here, for the event selecting 3 non-red balls, that is 5 out of 3. So there are 5 white and black balls. So getting one of each, say 3, is like saying the combination of 5 objects taken 3 at a time. So it's just 5C3. For this case, it's 5C2 because we just need 2 at a time. And here in this selection, we have 5C1 because we only need one non-red ball from the 5 choices. And of course here, we don't need any white or black ball, so it's just zero taken at a time. And as we all know, the formula for the counting principle here is multiplication. But since these are mutually exclusive events, meaning the event, say this is the first event, won't affect the other events. So it has a separate counting. Now we can solve for the final answer by multiplying each of these events and adding the total number in the last step. So for this one, 4C1 is just equal to 4. And 4C2 is equal to 6. 4C3 is equal to 4. And 4C4 is just equal to 1. Now for 5C3, the answer is 10. 5C2, the answer is also 10. 5C1, the answer is 5. While 5C0, the answer is 1. Remember that the operation here is multiplication, right? So 4 times 10 is 40, 6 times 10 is 60, and 4 times 5 is 20, while 1 times 1 is just equal to 1. So if this is the first event, second event, and this is the third, and this is the fourth, all we have to do now is to add these four different options or arrangement. So we have 40, okay, plus 60 plus 20 plus 1. The answer is 121. Again, all you have to do is add 40, 60, 20, and 1 for you to get 121. So there are 21 or 121 ways for us to choose four balls from a box containing white, black, and red balls, making sure that at least one is a red ball. Now, maybe you are thinking, is there another way for us to solve this one? Yes, there's actually another way, but you would find it more complicated because you can actually have the combinations one red ball and then three, say white balls and zero, say black balls. Okay, so what we're doing here is we are stating all the possible combinations of these colors, but we will have more given here, or I mean the solution will be longer for this one. That's why I just computed for the sum of getting white and black, because it doesn't necessarily say in the given that we need one, at least one ball or at least white ball. But if that's the case, of course, you need to state all the possible options here or arrangements. And that's all for this video. If you want to find out more about permutations and other counting techniques, please feel free to check our video lessons for those. See you next time.